Welcome to the Green Urbanist, a podcast for urbanists fighting climate change. I'm Ross. Hello everyone, welcome back to the podcast. Ross here. Today's episode is a conversation with Andrew Bullmore of VU.CITY. We sit down to discuss how 3D modelling, digital twins and artificial intelligence tools like generative design can be used to do better evidence-based planning and design and get more sustainable outcomes from new development or retrofit or extensions to existing buildings. As you can imagine, this is quite a visual episode, so I invite you to just open the description or the episode notes on your podcast app, have a look at the VU.CITY website while you're listening to this, and you just get a sense of actually what the software looks like as we're talking about it, because it'll probably make a bit more sense to you. But if you can't do that, if you're commuting or washing the dishes or something, don't worry, have a listen, you'll still enjoy it, and just have a look at the website later. It's definitely worth checking out. Thank you so much for having me here in VU.CITY's lovely offices. Do you want to just introduce yourself briefly for the audience?
Yeah, sure. I'm Andrew from the commercial team at VU.CITY. I've been here for around 5 years, so not quite from the beginning, but close enough, I'd say. Seen the company really grow over those last few years, and yeah, definitely excited about what we've got coming up in the future too. Brilliant.
So we want to talk today about 3D modelling and how that works for doing better planning, better design, and in particular sustainability. Can you tell us a bit more about what VU.CITY is, if people haven't heard about it?
Yeah, so VU.CITY, like I said, has been kind of going for 5 years. In that time, we've developed modelling of cities. So what it is effectively is a smart cities platform that allows architects, developers, planners, anyone working in the built environment really to understand their buildings in accurate context. So we started in London. We've currently modelled 1,700 square kilometres of London. So that's the whole of the city, Incredible. Everything within a London borough. We do cover some of the kind of areas surrounding that as well. We've moved into kind of Slough and Staines and other odd locations around as well. But yeah, so the clue's in the name. We are kind of city-based, looking at very urban areas. We now cover 26 cities across the UK, all to that same level of accuracy. So we model everything to 15 centimetres accuracy at rooftops, at terrain, at trees as well, to really help those that are working in planning and development to understand the impacts of the buildings in their environment, in the context that they're working in as well.
Yeah.
One of the key things is keeping those models up to date. So, of course, we fly over the city and capture that imagery, capture that data, but the first thing that happens is it goes out of date very quickly.
Especially somewhere like London.
especially inner London, where there are hundreds of applications going through, being approved on a monthly basis. We need to be on top of that to give a true representation of what's going on in our city.
And you've gone international as well, haven't you?
We have in parts. Our focus at the moment is very much the UK, UK planning, but that doesn't mean we're limited in where we could reach. We offer clients or specific customers kind of bespoke city licenses, and that could be anywhere. We can model anywhere in the world.
Yeah, it is great, and I mean, like, what I can vouch for is I've used it myself in practice, working as a consultant, and there's just not really any alternative, because the what you get access to, once you get into VU.CITY is just incredible. What I've used it for is for things like testing, large scale master plans, testing, doing building height studies or tall building studies for local authorities in London and other cities around the UK. And it's just an incredible sort of level of information and data that you can have at your fingertips very, very quickly, that otherwise is a very time consuming process to do. So yeah, it is really great. And I think, obviously one of the benefits of the 3D modelling, whether it's VU.CITY or any other sort of 3D models, is just that, you can convey that three-dimensional information in a way that you can't with plans, and that makes it really good for engaging with members of the public, people who aren't built environment professionals. But yeah, can you tell us a bit more about like how people use it, VU.CITY, for that like communication aspect, and particularly how that might relate to sustainability?
Yeah, so I mean, VU.CITY is a very visual platform. It's taking exactly some of those data sets that are typically formed in 2D and bringing them into the 3D environment, making them more immersive, making them easier to understand for those that probably aren't used to looking at 2D GIS data layers in plans that are often fairly hidden in websites on local authority websites and things like that. So yes, I definitely can go through that in a bit more detail. Kind of what I think we have to understand sometimes is that not everyone kind of takes information in the same way. I think personally I struggle sometimes to read a bit of information and then somehow form a kind of visual of that in my head. But when I see it, and I can see it on paper or I can see it in 3D, it's more, I guess the scale is represented better. And it allows you to kind of understand then the actual kind of the actual outcomes or the actual limitations or impact of something that you're trying to represent. But yeah, so if we're looking at communications of that data, we're seeing VU.CITY as an example being used quite heavily in public communication or consultation, really offering those that wouldn't have access to even viewing these things in 3D at a very early stage. So of course, often through planning, accurate visual representations might be required or created, or CGIs might be required or created at the right stage. They're expensive and they take a lot of time to do. So how can we portray or how can we share information with the public in a kind of cheaper way or a quicker way, more accessible, but also easier to then kind of react in a quick, proactive way with the local residents or local authority when we're kind of putting together ideas and plans and things like that. So through public consultation, definitely it can be a really good way of representing that data. That might be a view from the ground. That might be overlaying the listed buildings around the site or heritage sites around the site. It might be looking at the potential sunlight impact of a building that's going in as well. But all of these things we can react, or not necessarily react, we can be really proactive in visualising those in a quick way, given that all the data is available there, ready to kind of go straight away. Yeah,
exactly. And I think that just ability to see what is there already, what is in the planning pipeline, which I think is a really good feature of VU.CITY as well, that like upcoming developments, you can switch on that toggle to see what's coming up, and then you can put in your own proposals, just rough massing models, and you get a sense of how it all fits together in a way that is really difficult without that.
That's it. Definitely keeping it up to date with those planning proposals, that information that's coming through planning that residents might not necessarily be aware of, or others in the whole planning process might not necessarily be aware of, can really kind of add that level of data to that site and knowledge to that site to understand what the potential is 100%.
Yeah, exactly. And what about some of those other like data layers you have on there, things like cycle networks and census data and that kind of thing?
Yeah, we got hundreds of data sets across all of the cities that we're working in. A lot of those data sets are publicly available, but as I said before, it's just making sure that they are viewable and understandable, understood well to the kind of public and those applicants that are working as well. But in terms of data layers, we take a wide spectrum all the way from kind of environmental data layers, looking at flood risk zones and noise data within there. So along railway lines, we can see what the decibel levels are across there. Same with roads as well. You mentioned kind of those more kind of socio-economic data sets, things like deprivation areas. What else do we have in there? We got so much crime areas. Kind of looking at the even looking at house prices across sites as well. Yeah, through some of our partners, we have some of that data in there as well. But it all comes together to build a really good picture of that site and understand what might be sustainable now might not necessarily be sustainable in the future, or what was sustainable might not be sustainable now. So it's taking in all of those factors, not just the kind of green element, but also the social element.
Yeah.
How does a place work for those people living there?
Yeah, I think that's so key, because like if we take, I always take quite a broad view of sustainability on this podcast, of being about not just about carbon and emissions, but about social aspects, and ultimately about creating good places, that placemaking aspect, where people can live healthy, happy lives basically. And I think delivering development or projects that fulfill that, you have to have good analysis behind that. So I think giving people access to this sort of this level of information so easily and at their fingertips is really, really helpful for that. So I think particularly things like noise and air quality data or anything like that, which is often wouldn't be the starting point maybe for designers, doing analysis in a traditional way. But if that can be brought to their mind straight away, they might think, we might need to step the building back, put some vegetation in near this road, we don't want habitable windows by this railway line, or whatever that might tell you. Yeah. It's instantly giving you that information at the start of the design process, so it's really good.
Yeah, I think that was my first point when we initially discussed kind of having this conversation was, of course, VU.CITY can allow for kind of sustainable development, but there's no magic button to say make this sustainable. It involves those decision makers around the table to actually understand the data that's being handed to them, review it, analyse it, come up with those kind of good decisions, or make those good decisions for the good of the site, for the good of the kind of project in the future, not just what's relevant for now as well. So, but yeah, the more you think about it, the more layers you can kind of strip back, and the more sustainability comes into that conversation around where 3D models can be really useful in that conversation, in that process, and the data that's kind of shown on top of them. It just means you can be a bit more proactive with the way you're using it as well. Yeah. Instead of being an afterthought, just very quickly sift through the data and visualize it straight away, and take what you need from that at a very early stage as well, without having to do the kind of background work of getting a format data into your GIS software and then visualizing that in a way that's readable. It's really just making sure all of that's kind of hands off from the developer, the architect side, and you can just start visualizing it and reviewing it really quickly.
Let's get on to talking a bit about, I suppose, that design process and how people might be using it, VU.CITY or other similar tools, in terms of delivering more sustainable projects. So
yeah, of course I'm going to talk about VU.CITY a lot, because that's what I'm talking about every day, all day, every day. But if we just kind of go through that workflow, that process, it obviously starts with data. It probably starts with the site, but how do you pick the site? How do you know what you're going to do with the site once you have it? Perhaps you're an asset manager or a developer and you have land ownership. What's on that site already? Is there a building there? Are you looking to retrofit that site, or is the better option to rebuild, new build on that site? I guess those are the kind of questions you have to answer very early on. And looking at some of that data, we went over the kind of social data, the environmental data and things like that. You can start to put together quite a good picture of that. As well with the consented timeline, you can see what other people are doing around your site as well. If others are adding height, should you be adding height? Let's have a look at some of the comments, some of the reasoning for that's gone through those applications as well. But really at the very early stage, it's kind of deciding what is viable for the site and how you're going to kind of come up with the best possible solution for that site. So we're starting with data. The second thing would be to actually start kind of building massing within the site. Yeah. So we can either extend to the building that's already existing. In VU.CITY, we've got tools to do that are fairly simple kind of massing tools, modelling tools that you can really do in a matter of minutes. You can take your site and start adding these heights or demolishing them if you need to kind of create your massing from the ground up. But then at that point, what are we trying to assess? Is visual impact really important? Are there a lot of limitations around the site due to visual impact? They might be constraints that are dictated by listed buildings or heritage zones or conservation areas or key viewpoints. So London, you've got your London Viewing Management Framework. How does that affect what's going on there? It might come down to overshadowing. So if you're putting up a big massing, what's the effect going to be on not only the other buildings around, but also the open space around, and other elements like that. So there's lots that you can start to factor in at this stage when understanding the massing, where you're going with that. But once you've got that massing, how do we analyse that then? So what is viable, what isn't viable? We can look at the visual impact. We can look at that from the ground, from any point within the city, considering we've modelled a large area. And that's really, of course, architects have been working in 3D for quite a long time now. It's not a new thing, working in 3D, but often in the past that has been quite limited to the building they're working on, and perhaps a small amount of context around the site, depending on how much time you've got to model it, how accurately you're going to model that, and the level of level of detail that you want to go into with that. That can vary in its, usefulness when actually assessing the impact of that building. Because that impact isn't necessarily going to be within 100 metres or 200 metres. It's actually going to be, if you're looking at a tall building, could be
extremely far.
Definitely, So it could be over kilometres. But how can you test that in a quick way? And that's how having kind of shared resource of 3D data modelling over a large area can really help that process. And really what we're starting to see is that constraints or limitations and things that might have previously been noticed further on down the line in the project, they're actually getting picked up a lot sooner. So understanding the viability of the project and de-risking that project can be done at a much earlier stage, which hopefully leaves more time as well to understand the sustainability and the potential for creating better buildings, better places. If you can get beyond that initial kind of workflow really quickly as well. So that's looking at visual impact. Of course, you could take it a step further, and I think I was thinking about this earlier as to kind of, although that's quite a macro way of looking at sustainability, what are the kind of hidden benefits of using some of these digital processes to review that? One of them might be that the design team has to do less travelling to have these conversations, because they can just have a conversation. They can start reviewing the 3D environment from their machines, or not in every case, of course. You still need to do site visits. You still need to get out there and understand the site, but how frequent does that need to be? Or if there are other elements that could be picked up in that way, then maybe that's a sign of a kind of more sustainable way of working as well. Of course, that impact is so small compared to actually putting a building on the ground and the carbon involved in that process, but it's still something. So so I mean, that's looking at visual impact, and then of course that's great sharing that between the public and private sector in a kind of trusted way using VU.CITY. Now, I mentioned that the public and private sector are using it. In the UK, 60 local authorities are using VU.CITY to actually understand applications that are coming forward through the design process, and hopefully kind of de-risking them from the earlier stage as well. But so it's kind of just developing that trusted method of conversation through that process.
Because you're like a third party, aren't you? Between the local authority doesn't have to trust that let's say the architect is making an accurate model, because they have this independent model that everyone is using together. So
that's it. Yeah, I guess what we hope to think are gone are the days of masking and presenting a few images of what you want to show at varying levels of accuracy, because you kind of want to hide something, perhaps. What we really want to see is a more proactive conversation at the earlier stage, where you're very open about the impact of some of the buildings, but can work together in a trusted way using the same data to come to a good conclusion at an earlier stage as well and get the most out of the site.
Yeah, and to share as well, like this has like quite important implications for protected heritage assets and sort of, I think there's a lot of identity attached to skylines of our cities and assemblages of historic buildings and conservation areas and things like that. And where I've used the tool before as well is in the context of World Heritage sites, of which there's, I think, 3 in London and several around the country in different cities. And they're, international protection, the highest level of protection you can get for historic places. And, we all have a role to play in like preserving those, making sure they're maintained for the future and that new development doesn't, have a damaging effect on them in terms of their skyline or just detracting from their sort of special qualities. Yeah. And so, from a very strategic point of view, you can look at, something like that, which is very sensitive and very precious, and you can start to see how new development interacts with that and start to come to, conclusions about, is this going to be too much development in this area? Is it going to be too high, too bulky or whatever? Tested from these really specific viewpoints, which, is something that would just be an incredible amount of work without having VU.CITY to do that in.
Yeah, definitely. Looking at sometimes I end up spending too long looking at some of these kind of zones where you get clusters of buildings coming up and just looking at it visually without any understanding, you can see where clusters are appearing and how they're forming. And of course, there are guidelines and frameworks and looking at the city as an example, you can see how certain buildings have been kind of carved away where there's sight lines or views to St Paul's going through them. But even without any of that knowledge, being able to see it and understand it in a visual way is really, really compelling. And you then understand the thought process that's going through some of those as well. But yeah, it's really just the sheer scale of the modelling that we're putting together allows you to do that in a lot of those cases.
Yeah, and I think there's a longevity aspect to it as well, of like buildings that are basically that stick out like sore thumbs don't tend to last very long. They'll be the ones that will get torn down in 30, 40 years and replaced. Yeah. But it's the ones that are well designed, beautiful, but also well located, fit in with their surroundings and become a part of that like place's identity, that they're the ones that end up becoming the listed buildings of the future, basically. Is this a good time to talk about SiteSolve?
Yeah, okay. So we have a generative design tool called SiteSolve, kind of moving slightly away from VU.CITY, although part of the VU.CITY family and definitely something that we want to kind of bring into the kind of the context that we have there. What SiteSolve allows you to do is take an area, define an area, and you can use VU.CITY at an early stage to define that area and understand some of the limitations, constraints, using the tools that we have in there. But you can export that to SiteSolve. This all, as I'm talking about this, it all makes a lot more sense when you can actually see it.
Links will be in the episode description.
But it allows you to generate options on a site to different constraints or development targets and other things like that. So if you type in the number, the mix of 1 bed, 2 bed, 3 bed apartments that you would like, where your potential routes or roads might be through your site, even the height limits at potential points around your site, you can click generate and it will come up with a number of options for you. Those options generate really, really fast, but then they can be reviewed again back in the context of VU.CITY, so you can understand what a development that you're putting together what impact it might have on the wider context, but also you can test things like what the viewpoint might be from a particular apartment that you're putting together.
That's great.
You can have a look at the. We're just scraping the surface with this, just scratching the surface on kind of carbon tools and analysis. And it's really very much a first step. It's very difficult to, I'm sure anyone who has had this job in the past would kind of understand, it's very difficult to forecast the carbon on a site where you don't know what's going on underground, what's going on around, what's currently on that site as well in terms of the carbon. But we have a tool that will, in a way, generate a calculation to understand what these different developments are coming up with, what their impact might be above surface level.
Yeah.
But yeah, so we're seeing SiteSolve being used a lot to understand the viability or the capacity of sites that are coming up. So as a landowner, like I mentioned, or an asset manager, you can start to outline these sites and very quickly understand if there's potential there for development, if there's potential, and what sort of development as well. Like if you're looking at apartments against office space, what are the different kind of outcomes that you could achieve from those as well. But yeah, it's exciting for us. It's our kind of first step into generative design. It's proving really popular.
Great.
But yeah, there's loads that we can kind of continue to build in there. Definitely around the sustainability as well. Kind of moving on from our initial kind of attempts at carbon calculations and looking at other elements as well. One other thing that we do have in there, which kind of ties in quite nicely, is understanding kind of solar analysis. So within the blocks that would be generated within SiteSolve, we can see if they kind of fall within the guideline kind of sunlight hours across the year as well.
So like external spaces or internal spaces?
All external spaces,
yeah,
but internal to that site boundary that you'd be creating there.
Amazing.
Yeah.
Well, that's like a really key performance sort of indicator, isn't it? For key performance indicator for a lot of developments now, particularly, there's a lot of good policies and things like the local plan and stuff which are pushing for, the right amount of daylight hours per day within open spaces and play areas and habitable rooms and that kind of thing, which is quite a technical exercise to do. So if you can, get all that information up front with a couple of different options, it just gives you that, I suppose, that certainty that you're moving the design in the right direction.
Yeah, definitely. All of that kind of data is starting to be produced quite quickly, and I think that's the power of AI as well. We're very early in the journey of understanding artificial intelligence and how we can start to kind of plug into potentially other tools as well to use that information in a really clever way to get the most out of sites.
You might have seen that, I think it was the Architects Journal did a survey of AJ 100 architecture practices, and I think over 40% of them responded to say they are using AI tools in some form. Yeah. And so and as they said, they're only the ones that admitted to using it. So the real number might be even higher. So it is really happening, and it is really spreading quickly. And that might be a little bit of ChatGPT, or it might be, a little bit of help here and there. But I know, because I've spoken to architects who are using generative design tools, and they just say it doesn't take the creativity out of architecture, but what it does is it just lets us throw out the bad ideas really quickly.
Yes.
And then we use our skills as an architect to then refine the better schemes and make them our own, basically.
That's it. It's de-risking, isn't it? It's having a look at all the options up front or at a very early stage to then take on those more suitable options further. The same way that SiteSolve, it will generate options for you, but it's not saying these are your options. You can then manipulate them. You can draw in there. If you've got better ideas for the site, use those as the initial outline and we'll generate around it. But it's very much a kind of collaboration between the architect or the lead consultant or whoever's running that process, the expert in that field, and then the generative design element as well. But you're right. People talk about AI, and that could be anything from typing in a search in ChatGPT all the way through to fully kind of coherent AI models of kind of large developments and with all the internal flaws and everything produced. There's quite a big difference between the two, but I think I imagine the number's probably higher than 40%.
Probably is by now. I think there's a lot of fear around AI, and I share that thing of being like, we don't really know what's going to happen with it in the future. But I think for us as built environment professionals, like there's so much. I do feel like everyone sort of over delivers on projects because we do just do so much work for what is often not very sort of high paying work. And I think if we can start to use tools like this to free up time for the parts of the job that we really love, which is the creative aspect of it, or engaging with communities, or whatever, then that can only be a good thing. So
I think that kind of goes, or the same could be said with I guess the same could be said with VU.CITY as well. You've used the platform. Yeah. Now, you wouldn't expect to use some of the images perhaps that you create in VU.CITY in your marketing materials, or as a really high level CGI kind of generated image that you would use it in marketing or at the final stages. But a lot of it doesn't really matter at that point, because we're not selling those images. We're selling the conversation that you can have with the data that we've got in the platform. So it's, again, if you can't see it, it's quite hard to understand. But they're not kind of photorealistic renders of skylines or of your buildings within the city. What they do offer is a very accurate way of measuring the massing and the impact that that's going to have on other buildings, which is really important in that early part of the conversation, rather than selling that to the final residents of that apartment. Exactly. They just wouldn't understand that in that way. But
there are other tools for that.
Yeah, exactly. Yeah.
You've got an interesting case study around using VU.CITY for finding opportunities for solar energy.
That's it.
Tell me a bit about that.
Yeah, so we've been used more recently, kind of by one of our partner companies as well. We're part of this process, GIA. But yeah, one of the cities that we work with, we're really keen on understanding how they could potentially increase the efficiency or efficiencies across their kind of assets across the city. Now, because we have the whole of the city modelled, we are able then to determine all of the flat roofs across the city, and also determine what the potential sunlight on those flat roofs is over the course of the year, so we can get the potential of the sunlight or the solar panels that would potentially be on these rooftops as well.
Yeah.
So we can work that out at a really wide scale. Of course, it's good looking at the potential now, but also with approved schemes coming forward and other developments happening, then often some of those locations, they might actually start getting cast into a bit of darkness. So if you've got a tower going up next to what was previously a good site, it's no longer really that good for that kind of part of the year. But it's really kind of having access to all of this data, all of those flat roofs across a large area, can allow people to prioritise where the quick wins are, perhaps, the total potential, especially when you're looking at increasing the energy efficiency of buildings or your kind of portfolio of buildings, for commercial benefit almost at some points as well. Then you can find out really quickly, and then of course visualize it really well, for the client who's interested in looking at too.
I love that as a case study, because that's just obviously so replicable for other cities, around the UK and around the world. Like it's a great use of technology, and I think I can see, obviously local authorities using it, or maybe more academic studies using it to sort of make the case for how much of a city's energy could be provided, through rooftop solar in like quite a quick way. But also, as you mentioned, landowners, people who own lots of properties, and certainly in the UK we have these, the big estates that own huge amounts of property across our cities, and for them to be able to look in and say, right, from a portfolio point of view, we can fairly easily look and see what's the capacity for solar across our portfolio, and then see like what will the savings be for them, what's the decarbonisation benefits for them across their portfolio. That is quite impactful across the city for sure.
That's it. It's taking the impact away from building by building, which can look quite daunting if you're looking at the results from each building, to the wide scale impact, definitely. And it's not just looking at solar potential in some of these cases. It might be looking at where, of course, we need more housing, we need more density in some locations, but where existing structures perhaps could be looked at, given their flat roofs and ability to kind of start building on top of those buildings quite quickly. We could again look at those areas quite quickly as well. But yeah, I'm sure there's loads of different use cases that we haven't discovered yet, coming from this kind of data that's available now. Now we have the opportunity to do it. And that only really comes from having users kind of subscribing to it and kind of
experimenting with it. Exactly. Well, that's always a good sign, I think, if you invent something and then it gets used for purposes that you never even thought it would be used.
Definitely.
Do you want to talk a little bit about retrofit?
Yeah, we're also using, or being used a lot more on retrofit projects, or at least that's what our customers are saying. I'm speaking to architects all the time, and more frequently the projects are retrofit projects. So of course we're trying to shoehorn our way into to being useful in that way as well. But definitely for a client to understand what the potential for a site is, potentially a site that might have just been kind of written off in the past as an opportunity, given that it's already an asset that is I guess worthwhile at that point. How can we make it? How can we change its use to something that's actually more required more, or has a better potential for the user in the long run? So yeah, I mean, people are using VU.CITY to understand potential kind of additional stories on buildings. We've had a lot of, more recently, kind of penthouse developers using the platform, adding 2 or 3 stories onto buildings and understanding what the potential is there.
I mean, that's such a common one for when you're getting, because the expense of retrofitting, say, a historic building or an existing building. Typically, a developer, to make that stack up, will want to add a little bit more density onto it, maybe 1 or 2 more stories.
That's it.
So that, I can see that being an obvious one for testing in VU.CITY, just seeing like, what's this doing to our daylight, or overshadowing neighbouring buildings or views and that kind of thing.
That's it, and we're seeing that more and more, definitely with heritage sites or historic buildings. It just adds that extra level of interest and viability to the project as well. But yeah, it's really kind of seeing what the potentials are from those areas. They're kind of, I guess, re-exposing areas that have been hidden away or lost in the past. If you're looking at a central London rooftop or roof terrace, there's a lot to be gained from that. Even maybe green space or greening on those spaces as well. But there's a lot to be gained from maybe hidden viewpoints or parts of the buildings that haven't been kind of assessed or accessed, or potentially viewpoints from those buildings have been covered up because of surrounding building and height. Maybe if they're kind of putting a bit of height on top of that, then they're re-exposing their building again to some of those viewpoints across the city.
Yeah, and I think it's like a lot of cities, and I think particularly London, is promoting intensification. Like there's more and more guidance and more policies coming out saying, like, whatever way we can, let's try and get more housing in, more uses into our existing fabric in a way that is sort of sensitive and works with what's there. And like that's it's like a double sustainability gain, because you're not losing the existing buildings and the carbon that's there, but you're also maybe bringing in more intensity and more density to areas that maybe don't have that, that density of people to support like local services or public transport and that kind of thing. And you're maybe just helping to get in, those extra couple of homes here and there. Yeah. Cumulatively does help to sort of bring that bit more density, which we know is needed. Yeah, no, it does make a difference. And especially if you're an asset manager or a landowner with a lot of these properties. Yeah. Again, kind of going back almost to that point that we were discussing on the solar,
using data over a large area, how can you find all of these small wins or these quick wins? Might not necessarily be too quick if you're working in a very kind of heavily protected area, and that process takes a bit of time through planning, and of course you kind of the rest of it. But yeah, some of these might be quite quick wins that you can push forward in that whole process.
Yeah. Thank you so much for the conversation. It's been good fun.
Thanks a lot.